Okay, so now our next video here, we're going to look at, well, what if I just have a single source charge? What happens inside my visualization program with just that one charge, so we can start understanding what these visualizations mean. And so I'm going to end up doing a few things here and grabbing a few things. We're going to close that out. So this is my master package, but I've gone through, and here I'm going to 0, 0, 0, 1, 1, 1. And I create my grid for that, and then I've put just a single point charge in here. And it's a negative point charge. And I sort of put it in the middle because I'm going from 0 to 1, so this is at 0.5 and 0.5, but still in the z equals 0 plane. And I go through and I do the calculations. And this is the potentials, which we're going to skip over for right now. And this is the vectors. Okay? So I'm going to actually grab this image here. And put this in my notebook here for future reference so that we can mention a few things going on here and be able to explain some stuff. And so I'm going to mark down here that this was a single point charge, which was a minus q value, and it's at x equals 0.5 and y equals 0.5. Okay? Now, if I zoom in here a little bit more, you can start to see that these arrows point inwards towards the center, which matches what we know from general physics, which electric fields point towards negative charges. Okay? No, this is a negative charge, and they point towards a negative charge, because the electric field is the force on a positive test charge. And so if I were to put a positive test charge here, it would be attracted to the negative charge. And so it would get pulled towards that. Okay? So again, in general, we would have a, what is this? E field points Now, I'm going to go in here and real quick make a quick change on my package. And I'm going to make this a positive charge. And I'm going to rerun the calculation. I'll rerun the visualization of the electric field. Okay, so this is a positive charge. And so I'm going to come back over here to my notebook, and I'm going to paste this one. And right over here on the side, that this was a positive Q source charge, still at x equals 0.5, y equals 0.5. Okay? And again, if I zoom in, Which way did the arrows point?
Outwards.
Okay, so outwards, away from that point charge. Now, the arrows show us which direction it points. The color tells us something about how strong the electric field is. So if I were to have created this and put a little legend key over on the side, like we did with some of our stuff when you were learning Python, we'd see that red is the largest value and blue is the smallest value. Okay? Let me see if I can actually do that over here. I gotta see if I can remember how to do this. I gotta Google it here. This is what I want. I'll look at that later. Okay. But trust me, I know this particular color map that I chose to use, and this is the highest one. So this tells us that the electric field density is what's the color map, the magnitude of it, versus the stream plot part here is plotting the arrows. Okay? So regardless of whether it was a positive charge or a negative charge, the magnitude of the electric field is the strongest near the charge. Okay? And we actually see this two different ways, because what we have here is that the magnitude not only is the red the highest value, but the E field lines are closest together. And that was one thing that we had talked about, although it was a minor point back in our earlier stuff, in terms of when the E field lines are close together versus when they're further apart, we see stronger fields or weaker fields. Okay? Make sense? Okay. So what I'm going to do now is I'm going to come over here and I'm going to make a copy of this one, and I'm going to put 2 charges in it. And one of them is going to be at 0.25, and the other one is going to be at 0.75. And then my list of point charges will have 2 of them. So I need to come through, and I don't need to recreate my grid because that didn't change, but I have to recreate that, recreate the values, oh, I need to rerun everything. When in doubt, rerun the whole package. Okay, so I've got 2 charges here. Now, I had just sort of copied them so there's 2 equal charges. I could come up here and I'm just going to change this temporarily. I'm going to take the electric field vector section and move this above the potential section. That way I don't have to do as much. Okay, I'm going to make one of them negative, and I'm going to make one of them, so they've got different charges and different values. Okay? Okay, yeah, that looks better. Okay, so we've got a figure here, and I'm going to copy and paste this figure. And I'm going to create a new page here, and I'm going to paste this image. And just so that we can keep track of things, I'm going to also come over here to my notebook and copy what my charges were for that particular one, so that we can keep that information together. So we've got multiple charges now. So by looking at the coordinates, obviously I can come in here on my notebook and sort of write over this. I'll do it in white. Q1 is this one, and Q2 is that one. And by looking at my diagram, do the fields point the right way? Well, this one's a negative charge, and the electric fields are pointed towards it. This one was a positive charge, and the electric field vector is pointed away from it. And both of them are, the highest field is near the charge. You can kind of imagine, although it's hard to tell for sure, that this one, maybe the red section's a little bit bigger, and so maybe it's a little bit higher there than it is on the other one. But it definitely fades off as you go further away. And when we start looking at how these things added up, because this one is a little bit stronger, it dominates a little bit more than this one when we're sort of away from both charges. So if I'm halfway in between, the fact that that one is going up versus that one's going down, you see that effect in there. As opposed to if they had been equal charges, how that would affect things. And if I made them both positive charges or I made them both negative charges, we could start to see how the electric field is sort of bending due to those different charges. Now, I have another notebook here, which is the original multi-point master one. And this one I had 3 charges, and 2 of the charges were positive and 1 of them was negative, and they're in different locations. And I ended up plotting it from 0 to -1, and we see our little charges out over there. Now, we're going to get to the potential, and here's where you see, negative values are for negative charges and positive values are for positive charges on terms of the potential. We'll come back to that later. But you can start to see, and by changing your starting or your range of your grid, you can have it a larger range or a smaller range. You can move the charges around, so you can sort of zoom in on things. I don't have the interactive plots where we can zoom in on the plots. That's something that we're still sort of struggling with in terms of those values. But don't change this, okay? Now, what I'm going to show you here, so I'm going to stop this video right now.